All right, so welcome back. We're going to now continue with talking about our launching a person to space. You want to stick that back there just to remind people where we were. So we went through these sort of keyframes, and Alexander had identified the idea. The next thing we're going to do is try to think about how are we going to abstract this system and kind of what are the interactions we're going to talk about.
Right. So if you notice in the reading, we talk a lot when we have our cat coming out of the building that we were interested in the cat. And I think that is the same thing going on here in this case, though we're interested in the person and what's happening to them throughout the system. We may be able to consider the cannon, but I think, again, that is a level of complexity that isn't the focus of our question this time.
Well, I think even if we were dealing with this question about the cannon, the design of the cannon, I don't think we would be so much modeling what the motion of the cannon was so much as thinking about the cannon as something that imposed a set of interactions on the person. So I agree. I think we want to deal with this as a particle, right, and as a single particle, right? So we're sort of taking this person, compressing them down to a point mass that's located at where their center of mass is, and having that sort of point mass traveling through the atmosphere, but experiencing the effects of the atmosphere as if it were an extended body.
Right. So I think at this point we've made two assumptions. We're assuming that there's going to be potentially some angle that the person is launched at, and then the other big thing is we're assuming we're going to treat the person as a particle.
Right. Okay.
All right. So next is to consider what interactions are going on. So I'm going to start a new sheet. So what is interacting with the person as they are traveling, or what are the interactions that we need to consider at this point?
Well, at the beginning, they would launch out of the cannon, but if we're assuming that we start with some V0, then there's no launch interaction in this iteration of our model. So we have a person interacting presumably with gravity of the planet. And the person is flying through the air, so there's going to be some sort of drag force from the air.
Some sort of air resistance, or what we call drag. Is there anything else, Mark?
Well, I mean, you could imagine that maybe this person would have their arms out in some angle and be trying to create some lift, but I think probably drag and gravity seems like a pretty reasonable starting point. So
Yeah.
let's stick with that.
Okay, so I think it's time to start drawing more and
Yep.
think about some graphical representations. So my focus to start was thinking about this sort of phase two, what's going on when the person is going through the atmosphere. So if we have our person, again, here, we know they're traveling at some velocity with some velocity vector at some angle to be determined, we'll discuss later. But what we really want to get to is how those interactions are, like if this is the person at this point in time, how are the interactions impacting the individual and their motion? So we're going to draw our person again and go back to what Allison brought up, which was this idea of gravity first as an interaction. So the force of gravity acts towards the center of the Earth. So we're going to have some gravity force vector pointing down. And then we know the motion of the person is up based on this velocity. And air resistance, when we start talking about drag and air resistance, it acts in opposition to the direction of the velocity. So it would be pointing this way. So we'll call it the force, the impact of the air. So I'll define these over here just to make sure we're all on the same page. This is the force that depends on the velocity. That's a force of drag or force of air resistance, and this is the force of gravity acting on the person.
So I want to ask a question about this because it seems like some of these things depend on other stuff. Like gravity acting on the person, it seems like might depend on how high the person was, right? Like gravity goes as 1 over r squared, right? So if I'm at the surface of the Earth, there's less gravity than if I'm up high. So maybe I want the force of gravity to depend on where the person's located?
So is that a fair assumption, you think, to take at this point? Or could we say that gravity is constant?
Well, I guess the question would be, how would you decide?
Right. So would it be a fair assumption, one way or the other? My vote would be to say gravity is constant, simply because we're just trying to look at this short, potentially time frame. The person doesn't necessarily have a large mass to them. So I would vote for, at least in a first pass model, to keep gravity constant.
Yeah, I think I would vote the same thing. I'd probably think about the fact that, the thickness of the atmosphere is pretty small compared to the radius of the Earth. So the extent to which the person is going to be actually moving any distance away from the Earth's surface is small. So that gravitational force is probably just going to be mg throughout the flight, I would imagine.
And once we
So-
get a model that works, we can always come back and iterate
Yeah,
and
so
look
we
at
might
how it
want to
might
put a little
change.
kind of a little star there to say, hey, we might want to make sure that this doesn't depend on position in some important way. Because it could, like you could imagine, if you were shooting this person to Mars, like you would care about how the gravitational pull of the Earth depended on the position. But probably for this purpose, that's not going to change very much. And what about the air? Like that depends on velocity. What else does that depend on?
So when we think about atmosphere, we have to take into account the fact that density is changing over time. And so when we look at the force of air, it actually comes from an equation that we could start with now or we could save until later. What are your
Well,
thoughts?
but I guess I'm just thinking in terms of trying to articulate what these things depend on. It seems
Right.
like one thing that the force of the air depends on is kind of what the position of the person
Right.
is, because the position determines how much air there is. Like if they're outside of the atmosphere, there's no force of air.
Right.
Right. So I might say it does also depend on position somehow.
So maybe we'll add altitude here, because altitude comes then with things like density,
Right.
temperature, and pressures.
Cool. Okay.
So at this point, we might want to actually start creating some models from these interactions and moving more into the quantitative space. But I think that sounds like something we can do in the next.
That sounds like a great idea, Alex. Let's do that.